We need wideband to measure AFR, air-fuel ratio, at different operating conditions. What we have here in the greenish gold that's stripped down the middle is the narrow range of 14.4 to 14.9 we can read with a narrow range cell. Look at the blue power curve. The blue power curve peaks out way down the list here. It peaks out at around 13.2 is where we generate maximum power. This is a full air-fuel ratio number lower than we could read with the narrowband. Wideband, we can read this. So this is going to change our diagnostics a little bit. We can use this to measure and diagnose fuel delivery during wide open throttle acceleration. Since full power wide open throttle acceleration needs an AFR of 13.2, we simply use our scan tool to verify we're getting to a full 13.2. Now we're putting the diagnostics at the front end. Some people may say, why are you getting the diagnostics so early? We want you to understand what we can do with it to show you the value of the time it's going to take to learn how it operates. Now we can actually measure. If we have a fuel delivery problem, it will not be able to hold a full 13.2 enrichment. It will creep back toward 14. So this is a clear-cut diagnostic we've never had available to us before. Now the cold engine startup also needs about 13.2, just like max power does. When we're cold, 45, 50 degrees, somewhere in that range, a little lower than 70, we typically see a 13.2 air-fuel ratio. Now the AFR we're going to show you is made up so that it heats up in 20 seconds and can read these cold operating mixtures long before we can ever get to what we need to be looking at with a narrowband. So we can also start controlling fuel earlier and keeping it only as rich as it needs to be for engine operation. That's very important because we couldn't read the richness with a narrowband. We had to wait till it could finally get into closed loop. Closed loop now will come much faster. Fuel shutoff on decel takes us out to about 16.2 to 1 air-fuel ratio. We can read that. This gives us ways to diagnose fuel delivery during decel. If we have leaking injectors or some other source of fuel, we will not be able to get to 16.2. This is another point we could not read with a narrowband. So now we've established increased diagnostics by being able to use this and better emissions. Let's go and talk about what's going to be operating and see what we can do. And we've also said the narrowband just would not get us there.